Example number 3. The athletics department in a large high school offers 16 different sports. Now just to make this easy, I'm just going to number them all. So badminton is 1, basketball 2, cross-country running is 3, curling is 4, football is 5, golf is 6, hockey is 7, lacrosse is 8, rugby is 9, cross-country skiing is 10, soccer is 11, softball is 12, tennis is 13, ultimate is 14, volleyball is 15, and wrestling is 16. So, determine the number of sports that require the following types of equipment: a ball and an implement, only a ball, an implement but not a ball, neither a ball nor an implement, and either a ball or an implement, or neither a ball nor an implement. Let's just define our sets here. So the universal set is the set of all sports. B is the set of all sports using a ball. And I is the set of all sports using an implement. Now, I just want to be clear, so using an implement that benefits, or using a tool for the sport. So something like hockey would use an implement, or lacrosse would use an implement, whereas something like cross-country skiing, yeah, they have skis and they have ski poles, but that's a little bit different than using the actual implement to play the game. That might clear up some questions that could pop up. So let's just draw a Venn diagram so that we can see this. Now, what's difficult about this is not the actual figuring out of the numbers, but it's the way that we describe it. So how are we going to write this out? So, but with the use of a Venn diagram, we can very easily see which sports are which. So this is going to be my B set. This is going to be my I set. So now let's sort all the different sports. So badminton, which is 1, has an implement but no ball. So we would put it just in the portion that has implements. Basketball has just a ball and no implement. Cross-country running has neither implement nor ball, so we're going to put that out here. Curling has an implement but no ball, so we are going to put it right here. Football has a ball and no implement, so we're going to put it here. Golf has both a ball and an implement, so we're going to put it in the intersection. Hockey has an implement but no ball, here. Lacrosse has both an implement and a ball, so we'll put it in the intersection. Rugby has a ball. Cross-country skiing has neither implement nor ball. Soccer has a ball. Softball has both a ball and an implement. Tennis has both a ball and an implement. Ultimate has neither. Volleyball has a ball. And wrestling has neither. So let's use our Venn diagram here to answer the following questions. So A. So the number of elements that in the section that have a ball and an implement. So they must have both. So the way that we would denote it is the number of elements in B union. Oh, sorry, not union. It should be intersection. Intersection I. So that is this right here. That's where they intersect. And we can just look at it. There are 4 elements there. B, only a ball. So that we would say number of elements in B, and then this backslash here, I. The way that we say this is B, not I. So that means anything that's in B but nothing that has anything to do with I. So it's kind of like this, like bit out cookie kind of feel. So the number there would be the number of elements in B minus the number of elements in the intersection of B intersect I. So the number of elements in B we can just quickly look up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the number of elements in B are 9 minus the number of elements in the intersection, 4. So that would be 5. Question C, an implement but not a ball. So the number of elements in I, not B. So when we're talking about that, we're talking about this section right here that I'm about to highlight. Just this in here. Okay? So the way that we would do that is the number in I minus the intersection of B intersect I. So the total number in I is 1, 2, 3, 4, 5, 6, 7. So 7 minus 1, 2, 3, 4 is 3. And we can see that from our diagram here, 1, 2, 3. We can always use the diagram to check our work. Question D, neither a ball nor an either a ball or an implement. So what I'm saying is the number in B union I. So anything that uses a ball or an implement. So that is the number, we know from before, the number in B plus the number in I minus the intersection, so we don't double count. So the number in B we've already calculated as 9, plus the number in I, we've already calculated it as 7, minus the intersection is 4. So we get 12. Now the final question is finding the number of sports with neither a ball nor an implement. So that means that we're looking for the sports that are on the outside of the union. So what we need to do is essentially take all of the sports available to us and subtract what's in the union, and what's left over will be our complement. So this is how we denote it. Again, this is the most important part of the unit here. The number in the complement of B union I, okay, that's how we would denote it, would be the number in the universal set minus the number in B union I. The total number of sports in here are 16, and we know that the number in the union is 12, so 16 minus 12. Woohoo! Look at that. We have 4. Now let's refer back to our Venn diagram. Are there 4? 1, 2, 3, 4. Woohoo! That makes us real happy. So again, folks, the difficulties with this question, these kind of questions are not how many are there, but it's how do we write it out. And it was important today that we learned a few things. The idea of knots. Okay, so this is important. And also the idea of the complement.